In this video, we'll be talking about graphing a parabola from the standard form of the equation. If we are given a quadratic function in standard form, f of x equals ax squared plus bx plus c, then there are a few things that we can get from that equation. The axis of symmetry is x equals negative b over 2a. Since the vertex is on the axis of symmetry, you can find the y-coordinate of the vertex by substituting the x value that you found from this equation back into your standard form of your equation. And then using graphing techniques that we learned earlier about stretching and shrinking, a multiple of a, we can find other points on the graph. So let's do an example. In this example, we're asked to graph f of x equals x squared plus 4x minus 4. We can see from this equation that a is 1. Remember that the coefficient of x squared is your a value, and since it's not visible, it's 1. We also know that b is 4 and c is negative 4. To find the axis of symmetry, we'll use x equals negative b over 2a. So we can see then that our axis of symmetry for this parabola will be negative 4 over 2 times 1, which makes our axis x equals negative 4 over 2, or x equals negative 2. So the x-coordinate of my vertex then is also going to be at x equals negative 2. Let's go ahead and draw in our axis of symmetry. The vertical line at x equals negative 2. Now to find the y-coordinate of our vertex, we need to just put this negative 2 value back into our equation. So y is negative 2 squared plus 4 times negative 2 minus 4. So my y value is 4 minus 8 minus 4. So y equals negative 8. Using these two values, then my vertex will be at negative 2, negative 8. Negative 2, negative 8. This is my vertex. Now I can see that my lead coefficient is 1, because a is 1. This means a couple of things. First of all, it's going to open up, and the width of the parabola will be the same as our basic graph. So we're not going to do any stretching or shrinking. So if we open up then, go right 1, up 1, right 2, up 4, left 1, up 1, and left 2, up 4. There are a few points on my graph. I could go write 3, I'd have to go up 9. 3, up 9. 1, 2, 7, 8, 9. That would put me right here. And then I know that my axis of symmetry, I can just reflect this point 3 units to the left of my axis. So this point is also going to be on my parabola. So let's draw our curve. Notice too then that my domain is all real numbers, and my range, we start at -8 and then continue up, so -8 to infinity.